Hi everybody, it's been a long time, but I'm back and ready to record some more live coding. Today I'm going to be working on Audacity. I've been working on the iPhone stuff quite a bit, and hold on while I turn down my mixer, it's kind of loud. Yeah, that's been going well. I actually just submitted an app to the iTunes store. So we'll see how that goes. There's some pretty cool stuff there, but today we're working on Audacity. So what I'm doing is I've been trying to implement a, what's that called? Let me put this on the front. An on-demand feature is something that runs in the background, so like when you're loading a file. If I loaded a WAV file, oh, that's not going to work right now. Shoot, it might work. It might work. Let's try it. When I load a file, a large file like a 700 megabyte file, it could take like a minute to import, but instead it'll import immediately and just load the parts you want on demand. You can click on the waveform to change where you want to load and such. So here's an example. Let me find the largest wave file. Looks like I don't have really big ones, but yeah, that's right. It crashed right now. That's because I have it set up to use FFmpeg, and I've halfway implemented it, and I have to debug that today. So I don't know if you can see. You probably can't. On the bottom there's this filter, and I have to select all files. Then if I do find my large wave file, like such, see how the hatch thing loads in the background? This is a very short one, so it's not the best example, but you get the idea. Now I'm going to go ahead and intentionally crash it, so I can get my good file list back. Yeah, so FFmpeg on-demand loading will do essentially the same thing, and I've got pretty far with it, but now I'm stuck doing some debugging, and it's not the kind of happy debugging where you've got a pretty clear trail and it goes pretty quick. I've been looking at this for a couple hours now, including yesterday, so probably like 4 hours total. This is just the debugging part. Now, let me see what we can do here. I just kind of wanted to stream this so I could talk out loud, and maybe that would lead me in a new direction or something. So I guess I'm going to go over several debugging techniques. I've built this for debug, so I can do something like this. Use GDB, and it'll tell me just where the program crashes. And I've got a lot of weird printf statements to say exactly what's going on, so I can track every little thing. So obviously when it's running in debug, you'll see that it does run quite a bit slower. It's interesting that it crashed there. Seems to crash. No, I'm not sure. So if we look at where it crashed in the write simple block file. Yeah, that seems to be where it is crashing, but that's not where the first problem goes on. So I mean, this is why debugging can be hard. If you do some weird memory error, like you write into the wrong place or you overwrite past the end of the buffer, then you're often stuck with these kind of ambiguous, almost seemingly non-deterministic crash points like this one keeps hopping around, and that's because this is the location of the crash. There's some weird things like this format should probably not be 117, but maybe that's part of the memory overwrite issue. We have constants defined, probably enum. As you can see, where is it? Right, starting from here. Yeah, this isn't a good example, but anyway, I'll show you the other option we have. We can use valgrind. And I've looked at this a couple times, but depending on which file I open, it'll crash in a different place, and that's indicative of some weird memory crappiness that I'm doing, like overwriting. So valgrind will run the program really, really slow, but that's fine. So let's just be patient for a while, and we want to look for those memory issues. The thing about memory issues is that they won't crash immediately. So you got to find something like valgrind will tell you when you're writing past the end of something. I don't know how it does that actually. I understood it at one point in time, but it seems like that's. I'm not. Yeah, it's interesting stuff. Anyway, right now I just want to be a user, so I'm going to click Do Not Recover. It's not just when you write into invalid blocks. That's the cool thing. I believe it catches other kind of errors, like you write past the edge of the boundary. It probably aligns, I think it aligns malloc to, whatchamacallit. It aligns it such that everyone's on its own page, so you can have lots of artificial invalid boundaries. I'm going with that for now. So we'll open one of these MP3s with on-demand FFmpeg, and we will see the program runs a lot slower, so you can actually see the import before the hatching on-demand part pops up. And once that happens, boom, we see, okay, this is normal, this always happens. Okay, then we get a lot of stuff spit out at once. So this is all good, there's no errors. These are my printfs that I'm using to debug. And there's lots, yeah. So, oh, that's interesting. Before the first... Ah, okay. Isn't that neat? It says that I'm not sure what this message means, but if that's talking about a malloc that's that large, I would be very surprised. Looks like about a gig. So next interesting message is that we are doing invalid reads at this location 1 0, and this is just the start of the buffer. So yeah, that's neat. I'm going to copy this, paste it on my next screen, which is not visible to you. And I'm going to look for, so this is the debug statement, the printf, just spewing out every step. I recently changed some of, I found the bug here. This formatting is not that good. we'll need a second. Yeah, so one of the tricky things about this is last time I used FFmpeg from the client API side is maybe 2 years ago, and it was still, everything was using uint 16, everything was using 16-bit signed integer audio. Now they use float and other formats. So introducing that has caused FFmpeg in Audacity not to work with this on-demand stuff. So I suspect that the crash is related to this kind of thing, where now we are not I have to make sure this size is valid for one thing. So maybe I'll print F these. Yeah, I'm gonna just do that because, you know, I'm not sure that we even have a decode size here. Wait, what is this? Okay, this is after we decoded something. This is not the silence. The silence issue is... Huh? Interesting. So... it's kind of complicated, but we use internal cache because each of our wave tracks in Audacity represents a single channel, and we decode each of these on different background threads. So we cache the data so they can be shared across the 2 threads, and the decoder can run independently on a different thread. Alright, so this is the place I am suspecting right now. What does the malloc look like? Well, we have an amount, we have a cache, a sample size. I kind of want to see what sample size is. Yeah, I do. Because if that's something like... yes, that's highly suspect. So right here, I'm just going to new printf, and we'll just say sample size %. Is it a LU? It might be LLU. Where am I getting that sample size? It's from ffmpeg.h sample size. It's an int. Okay. How about that? And then scm sample size. Alright, let's try. This is a little tedious. I mean, I could go through a debugger, but it'll take about the same time. Gotta rebuild. Don't need that. Alright, so when we're talking about zeroing out, that's the first thing that happens. And sample size is 0. Well, that's not good. We're mallocing